Okay, thank you very much. Thank you for being here for the last moment. There was no presentation about hydrinos in this conference, so I thought it would be a good thing to trigger a discussion about that. So I'm going to make a short presentation to see if there is a debate about that. You probably know this hydrinos theory by Randall Mills. By the way, who thinks this hydrino theory is a valid one? Please vote. Okay. 1, 2, 3, 4, 5. I see that Jürgen is not in the room, otherwise we would have 6 already. So according to this theory, these hydrinos are shrunk objects composed of a proton and an electron. And Randall Mills proposed several methods to test his theory. And all these methods are summarized in this presentation on this Brilliant Light Power website. You see, you can download this analytical presentation. And among all these methods presented in this analytical presentation, there is one about gas chromatography. And the next 3 slides are coming from this Randall Mills presentation. Here he presents the gas chromatography, so you know about that. He used helium as a transportation gas. And he says that these hydrinos are evolved from a gallium oxide collected from a sun cell heated at 950 degrees. He also says that they duplicated these results 24 hours later. You are going to see why this is important. Okay, so you see a chromatograph of this gas coming out of this cell. And indeed, you see several peaks. There was hydrogen and methane in this gas, so you do see the peaks corresponding to hydrogen and the other one to methane. But you see an additional peak here before the peak of hydrogen. It means this is something lighter than hydrogen. With a positive peak, he thinks this is because these things are lighter than hydrogen. If these are hydrinos, of course, they are much smaller, and they diffuse faster. This is not the only picture he produced. In this analytical presentation, you will see 2 or 3 such chromatographs, you know. And 24 hours later, he repeats the measure with the gas, and there is no more hydrinos. But you still see the peak for hydrogen and the peak for methane, but not for hydrinos. And he says that the novel negative peak with shorter retention time than hydrogen was absent due to diffusion from the vessel. Interesting. So let's take Randall Mills to his word. And if hydrinos exist and behave as claimed by Randall Mills, it must be possible to test their capability to escape from a metallic vessel. This is what he says. Okay? Let's try it. This, how to produce hydrinos. This is also explained in Brilliant Light Power website. They made, maybe you are aware of that, they made a test also of the ultraviolet spectrum coming from hydrinos created during the transition to hydrinos in such a cell. And to produce the hydrinos, they just make arc discharges in low pressure hydrogen. Easy. If it is as easy as that, we can imagine this thing. We can imagine this vacuum chamber at, for example, 200 Pascal, and this is a sealed vessel, completely gas tight. You know, this is a special capsule, a space capsule, you know. Nothing can go inside or outside. You are going to see how. Out of this container, there are some electrical connections and a gas port. So this is completely sealed. What is inside? Indeed, inside there is an arc to generate the hydrinos. There are other things we understand in a minute. There is a pressure gauge to measure the pressure inside this black vessel. And there is another one to measure the pressure in the chamber, okay? So, how to operate this device? At first, this is open, the gas port is open, and you pump everything down to 100 Pascal, so you have the same pressure inside because the gas is escaping gently out of this vessel. Now you start to seal this port. There is an ingot of tin you heat up, and this is heated, and after complete solidification, this siphon becomes solid and is sealed, okay? So, at this time, you can increase the pressure in this vacuum chamber to 200 pascals in order to make sure that no gas will escape from out of this vessel to the chamber. And from this point of time, nothing can go in or out of this vessel. That's it. This is sealed. Okay, there is a small problem. There are many other things in this picture. I don't want to lose too much time about that. But indeed, one of the problems is that if you produce hydrinos with an arc, you are going also to produce monoatomic hydrogen, and monoatomic hydrogen could diffuse out of this vessel. To avoid that, there is a metallic screen enclosing this internal space so that all atomic hydrogen, before reaching the wall, would have to cross this mesh and to recombine. So no atomic hydrogen would never touch this black vessel liner. And you have to produce atomic hydrogen without producing hydrinos, and this can be made easily with a hot tungsten wire. H2O is a poison, so you can get oxygen out. And the test is positive if the pressure in vessel 1 remains stable with this hot wire. Okay, at that time, if this, it is sure that this vessel is tight, even in spite of the presence of atomic hydrogen, you can start the generation of hydrinos. Randall-Mills claims that H2O is a catalyst for the production of hydrinos. Okay, so then let's operate an oxygen donor to give some H2O again back inside the vessel. Maybe during an initial phase, some hydrogen may get dissolved in all these elements. So this is the reason why you see there is a small container here of hydrogen embarked inside this spatial capsule, this space capsule. And if necessary, you can heat up a plug here to diffuse the hydrogen from this to the vessel space, or if you put too much hydrogen, you can heat up this plug to remove this hydrogen at times out to this vacuum pump. So we can indeed operate that as we wish. So after some times, some weeks, some months, I don't know, you will see if the pressure decreases and if indeed some hydrinos went out. So, you know, conclusions. Could this experiment show that shrunk objects exist and can diffuse through a metallic wall, as Randall-Mills claims? Would this experiment be considered a valid contribution to prove or disprove the theory of hydrinos? Please vote. 1, 2, 3, 4, 5, 6. Oh, okay. Thank you. Could this experiment be adapted to test the theory of EDOs? Because Jean-Luc Payet told us and Andrew Mullenberg told us about EDOs. Talking to Jean-Luc, he thinks that EDOs are also shrunk objects, and maybe if hydrinos can escape, maybe EDOs could do as well. But okay, this is for the future. Sorry? Electron deep orbits. You didn't listen to Jean-Luc Payet. Oh la 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 la.
Andrew Mullenberg.
I can do this presentation again if you wish. No. Okay. If you think that something should be modified in this setup, it can be at this time. This is no problem. A last question. Who would like to do this test? Please vote. Thank you.
Thank you, Doctor.
Thank you. I think Mills has done this experiment. This is one of the proofs he had at the beginning that there was hydrinos. He was saying the pressure was going down by itself.
Yeah.
But
in this analytical presentation, you see another slide stating that in argon bottles, we should take care of argon bottles because argon is purified by tracing out the remaining hydrogen with oxygen. You get some hydrinos mixed with this argon. Strangely enough, these hydrinos would not escape from argon bottles, but would escape from this sun cell and things like that. So go ahead. But I want this debate to be between you. Next, please.
I will never do that experiment anyway. Too complicated. I mean, this is on PowerPoint, it's easy, but not in the real world.
Okay, back.
Is it possible that the hydrino, if they exist, they combine in some molecular hydrino molecule, and they not shown on the chromatographic?
Maybe, I don't know.
That maybe that they disappear on after 24 hours. Maybe the combined in molecules. I don't know.
Maybe. So they disappear. Francesco, maybe. Oh, sorry. Yeah, Lutz.
2 questions. The first one is a very general one. If hydrinos really exist, why is it only with hydrogen? It could work with other atoms as well. The theory of Randall-Mills, in principle, would apply to all atoms. So that's the first question. Why is it specific to hydrogen? Second question, I think Randall-Mills gave examples that these shrunken hydrogen attaches or absorbs to other materials, to solids. So why do we think that this is seen as a gas pressure in this experiment? Because they could absorb to solid states and not be visible as gas or as pressure.
Okay, thank you. The second question I can answer. If hydrinos stick to something else or escape from the vessel, they will simply disappear in the inventory of hydrogen. And you will see the pressure of hydrogen. The only thing you measure, this is the pressure of hydrogen. You will see the pressure of hydrogen decreasing. You can only see that in this experiment.
Okay, good.
Okay, that's all. You had the first question I can't answer. Who would like to answer the first question? You, please.
Okay. When you make arc discharge, you can introduce atomic hydrogen that later recombine. So you have, when recombine, a little bit pressure drop. How you can separate?
I told you that there is a metallic grid here. And you know this atomic hydrogen, they recombine easily on metallic walls. So if there are atomic hydrogen, hydrogen atoms coming, wandering around, they will have to go through this mesh first, and there they would very likely recombine. So no atomic hydrogen would come easily to this wall, because they would be recombined along inside this mesh. This is the idea.
So I wish I had seen this presentation when we were talking last night. I would have had a lot of other comments to make to you. But I've worked in the area of making vacuum vessels and high vacuum physics and residual gas analysis for 40 years. So there's a lot of comments I could make about your experimental design, as was sort of alluded to, so I should talk with you about that. But certainly I would do away with heated valves as a way to trying to melt metal and stuff, because that's going to change pressure that'll be impossible to differentiate from the changes that you're seeing due to any hydrino formation. So I'll talk with you later.
We can talk together. It will be a pleasure. But I am not going to make this experiment. But if we find someone a laboratory who would like to try it, then we can talk to his lab. Yes, Francesco.
Okay. I worry about the Langmuir effect that he found in 1928, where a special kind of glass is able to absorb hydrogen atomic, but not molecular. So for some reason, there is a material that has the same characteristic of the glass of Langmuir that we use every day in our experiment. So you can be filed because we observe several times reduction of pressure, because this material absorbs only atomic hydrogen. So you feel decreasing pressure. So it's a nice experiment, but this effect, Langmuir effect, has to be taken under strong consideration, I think. I have the original paper of Langmuir. Just one page is the experiment.
Okay, thank you. Atomic hydrogen, probably we can expect them anyway. So I hope, as a metallurgist, they will saturate wherever they have to go. And this is the reason why there is embarked on board some more hydrogen to replenish as much as you want for a time.
One other possible thing to consider is that Mills considers that the only way to form a hydrino is to catalyze it with an evanescent coupling out of its ground state orbital into the fractional orbital. And he lists a number of catalysts that have similar normal states to the energy that would be catalyzed out of the hydrogen to create that. It seems like you could create some high pressure hydrogen sealed vessels, one with a catalyst and one without a catalyst, and see if the one with the catalyst decreases in mass compared to the other as a comparison.
Thank you. He claims that H2O is one of these catalysts. This is the reason why you can get H2O out thanks to this oxygen getter. You heat it up if you want to remove oxygen, or you can increase the quantity of H2O by giving off some oxygen donor. Oxygen donor here. This is, for example, I don't know, it could be nickel oxide. You heat it up and it will react with this hydrogen to give off some water. But this is a good idea. And you can check also if you get all the oxygen out, all the H2O out, are you still going to see a pressure decrease or not? If you give now some water vapor in, are you starting to see a difference? Nancy, you wanted the microphone.
I'm just wondering about the Schrodinger equation. What does it say about the prediction of hydrinos? Can it explain that there is such an existence of hydrinos? The Schrodinger equation, does it say anything about it?
Who would like to answer this question? I can't. But there is a whole literature on this internet site, Black Light Power. If you refer to it, you make up your own mind. And, well, who knows?
I can comment on that. I don't know for sure about the Schrodinger equation prediction of hydrinos, but I know that the Klein-Gordon only predicts a much smaller set of solutions. But when you go to the Dirac equation and you've added in spin and relativity, you get a full set of lines, the kind of lines that Randall Mills predicts with his classical, electromagnetics solution. But it shows up best in the Dirac equation that includes both spin and relativity. But Young Kim had argued for many years that these were not real states, and that's why we have this whole issue of looking to see if anybody can find any evidence at all that these fractional states of hydrogen can exist. I mean, but he made arguments that said, oh, these are just imaginary solutions that don't exist in nature, where others believe that there's no reason why they shouldn't be as valid as any other state, but nobody can find them, but hydrinos are very hard to detect.
Shouldn't be a well-defined emission line when from the grand state it's moved to the hydrino and back and forth, and that should be detectable? Like when you move from one energy state to the other one at the hydrogen atom, when you move from the grand state to down or up to the hydrino level, shouldn't be an emission and well-defined, frequency.
I think Muhlenberg says that there's not enough momentum to create a photon to go between those states, and that
under H.
right. So because of that, you have to transition by an evanescent coupling.
Yeah.
So you can't detect it by the same way that we normally detect hydrogen or anything else.
So this is the point. He measured here in this setup the ultraviolet spectrum of this transition, They made this with with an arc discharge in hydrogen to measure the spectrum coming out of this of the arc, indeed, and they measured the presence of a continuum emission of ultraviolet light, which according to Randall Mills, cannot be explained by existing theories. I'm just quoting. I will not argue about that. So, and for him, this is the first evidence of the existence of hydrinos, this ultraviolet spectrum, continuum spectrum. Okay, maybe. I don't know if this is a black body at very high arc temperatures or something else.
Thank you, Jacques.
Thank you.